Welcome for joining this free workshop on the science of learning. It's a hot topic, or it will be if it hasn't crossed your purview yet, but my guess is it possibly has. There's been a lot of interest in the science of reading, and I like to go one level up, think about, well, what are some things based on the research and the evidence on learning in general. My curiosity about this topic came about around 2016 when the organization that I was part of, Teachers College Reading and Writing Project, was really into making tools and toolkits. And I was thinking about, what is a tool and how do they actually work? What makes them work? I know they can be pretty and well designed and awesome to use, but what makes them work in the brain for student learning? And so that started me down my path. And I'm going to give a very brief presentation. And so, stay tuned for more on this topic from me and from others in the coming weeks and months. But I know it's a busy night for everybody, so I'm just going to give a brief rundown and overview. But should you ever want to learn more, just stay connected. I'm working on an article about this that I hope to publish. But let's get started with the science of learning. The message I like to send to get started in something like this is this paradox that arises when it comes to learning something, and that is, the more one knows, the more one can learn. And the inverse is also true. The less one knows, the harder it is to learn things. And it makes sense. Like, the more information, knowledge, and skills and abilities that you have stored in your brain, the more, when new information or facts or knowledge or skills, things that you can do, come along, they can stick to the stuff that's already there more easily. Whereas if there's less there, it's harder for something to stick and it can float away. So that's sort of the message that I hope to send. The first thing I also want to do is to set the stage. And I want to tell you this so that you can be discerning when you're thinking about the science of learning and you're looking at science of learning tools, resources, or with other individuals who might be sharing stuff that have the science of learning. So I'm going to start by setting the stage a little bit about what I consider to be the most useful and practical science of learning information that we can use in our classrooms with students. So I want to start by sharing that when you hear science of learning, you might be hearing something that might be coming from neuroscience, or you might be learning something that comes from cognitive psychology or cognitive science. Now, they're very related. It's kind of like when I went to grad school, there was a literacy specialist program, and then there was a reading specialist program. It's a little bit like that. Like, there's a lot of cross-pollination going on, but they do different things and we can learn different things from them. And from that, I'm going to make a claim that one of them is going to be more useful to your craft than the other. Not that they can't inform things, but when I say useful to your craft, I'm talking about these are strategies that you can teach students and strategies that you can teach students to teach themselves to transfer independently. And so that's why I'm going to suggest, my argument is, if you trust me and are willing to go along with me, that we lean more into one side of the science of learning. Not that we can't learn lots of great stuff from the other. All right, so one is neuroscience. Neuroscience studies the brain and the brain parts and their functions and the synapses and the neurons and how they fire and what they do. And a lot of that's done through like brain scans and what lights up when this happens and what part of the brain is in charge of this. Neuroscience gives us a lot of great information. I'm going to tell you some of the key information that it tells us. And what my argument is, it's less practical in terms of, is it something that you can teach kids to do to help their learning? Is it something that you can teach kids to do themselves to help their learning? Not necessarily. They're important things. They're things that we need to keep in mind that if we want to, change things and make things better for all students. But it's not like something that you can now go in and like teach some neuroscience to kids and now they're going to learn better. But you can teach some cognitive science to kids and they'll learn better. Cognitive science, or cognitive psychology, if you want to be more specific, studies how the human brain learns, how it retains its memory, and how it transfers the information. So on a practical level, when you're thinking of science of learning, I want you to pay attention to what people say. Are they talking about neuroscience? If they say neuroscience, your feelers should go up and say, okay, I'm going to learn some interesting stuff here. But it may be the case that perhaps it's not quite as applicable as cognitive psychology, cognitive science strategies. Now that's my argument, right? So I I laid out the teaching. My argument is you're going to find more value in cognitive psychology, cognitive science. So pay attention if you ever listen or read other things. What kind of science are they talking about? And it's not that we can't learn some good stuff from neuroscience, and here's some great stuff we can learn from neuroscience, like the importance of sleep, right? And we want kids to get sleep. It's not like you can go into your classroom and say, let me teach you about the importance of sleep. Like you can try to influence that at the end of the day and you can do things, but it's not like a mini lesson on, it's not like a small group on like, let's get some sleep. Or, I mean, certainly you could do that. You could inspire kids, but it's trickier. When kids leave the door, you don't really have control over how they're sleeping, but sleep consolidates learning. Sleep's essential for learning. And we know this, that emotions affect learning. Try learning or performing on a learning task. If you're anxious, you're stressed, right? You're scared. That's important. So there's certainly things that we can learn about helping kids, calm down if they're feeling anxious, or creating environments that are welcoming, that feel very conducive for learning. That is definitely important. And you can definitely create a classroom culture environment that's suitable to that. So you can see, like, I'm not saying there's nothing that you can draw from in neuroscience. I'm just saying in terms of practicability, like I'm going to teach you I'm going to tell you some strategies that you can actually like teach kids to use. That's going to actually help their learning. Other things are that movement burst learning. A lot of the, and by the way, a lot of these are common sense, which is nice. I always like when science and common sense align. Like, hey, you should get your rest. Like you should be in a peaceful state to learn. Moving around is good for you. And then obviously novelty grabs attention. Anything that is new and different is going to draw your attention. So that's pretty obvious. So neuroscience is great, but I am much, 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 much more a bigger fan of cognitive science. And so here's what I want to tell you now. This other setting the stage, I want to talk a little bit about knowledge and memory, because that's going to help us think about the science of learning. Now you could talk to any, science, brain scientist, cognitive scientist, and they'll talk about different kinds of memory or knowledge. Pardon me if I use them interchangeably. Knowledge is the stuff that you actually can know and do, and memory is the mechanism that allows you to take it in and then also recall it and transfer it. If I use those interchangeably, forgive me. Somebody who's a stickler would say actually they're different, but I'm going to use knowledge and memory probably interchangeably. There's three main kinds, and depending on what kind of scientists you talk to, they might be like, well, actually, there's six more. Everybody's got their own framework of things, but here are the three biggies. And what I want to tell you, that of these three biggies, there's two that are most pertinent, I believe, to the strategies that I'm going to be sharing with you. And you can probably jive with these two, because when I tell you what they basically are, you'll be like, oh yeah, that's basically two of the big things that we talk about in education. So there's semantic memory. This is basically facts, content, concepts that you can retrieve within a moment's notice. That if I were to ask you 1 + 1, you could immediately say 2. If I said, what color is a polar bear? Without even thinking, you could say white. If I asked you to think about the very first phone number you've ever dialed or had to memorize, you could probably, maybe you take a moment, you could probably recite it. And then the next thing I like to say is, well, when's the last time you dialed that number? And for many of us, it could be decades is the last time you dialed that number, but yet you could retrieve it. That's like a fact, something to know. Mine is 386-9876. I don't know what the area code was, because I was I was like the last of the free range kids. I'm like late Gen X, early millennial. I'm right on that cusp, and I would ride my bike all over town. And so I had to call home to check in and tell them like, hey, I'm over at Matt's house. I'm at Jake's house. What time do I need to be home? But I haven't dialed that number in 35 years. That's semantic memory. Here's a brief way to think about it. Think of this as content. Right? In schools, we call this content, science, social studies, math, things to know. You might even argue that vocabulary and grammar and spelling are also content, things to know, things you just need to know and retrieve from your memory. The other biggie is procedural. I think the best way that we can understand this in schools is that it's skills, right? Things that you can do with automaticity. You can ride a bike, that you can play an instrument, you can do art. And when you know a lot of things in writing, you write fluidly. If I asked you to all write for 1 minute, you could probably write for a minute. You're probably not thinking about the mechanics of what your hand's doing at all. You're thinking in your mind about what the words you're going to put on the page. That's a procedural memory. You can just do it with a lot of automaticity. And often these two are at odds. And I don't want to get into this debate, but there are many, and this debate goes back to ancient Greece, like what starts first, content or skills, skills or content? And there's some people who are like, it's all about the skills, and other people, it's all about the content. And I of course, take a contingent approach. It depends on what you're doing. Some things you need to know before you do the doing, and some things you only need to know a little bit. You could just start by doing the doing right away. The third big kind is called episodic memory. These are the things that you remember, that first kiss that you had, the first time you fell off a bike. There's these episodes, and these aren't very trustworthy because a lot of times they can get changed and revised over the years, that you can misremember or forget a detail, or that's why they say, memory is not always that great in terms of getting witnesses and what people remember. If three people could see the same thing and have three different stories. But episodic memory is important, and it can play a role in the classroom. Like if you remember a teacher who did something really fun and interesting along with the learning, like you'll never forget that moment. Maybe you'll remember the moment better than you remembered the learning. So episodic memory is important, but the biggies that I'm going to talk about are going to be talking about semantic memory and procedural memory. You could think of anything that you're learning or have learned, or things that your content that you're learning or have learned, or skills that you're learning or have learned. So the last time I did this was with a group of colleagues, and the content, I just had somebody throw out content, and they're learning about they're taking a morphology class. And the procedural stuff, the colleague was learning to crochet. So we could use some of the things like that. Although I don't know crocheting as well, I might mix it up with knitting. So if you're a pro, you can call me out. But I did needlepoint as a kid. My mom taught me to needlepoint. It was a fun thing to do in front of the TV in those winter nights growing up in Minnesota. So I'm going to use these as I share the cognitive science strategies. I hope I'm not going too fast for you. But like I said, this is just a very brief overview and teaser into this information. What I want to share with you that's going to kind of connect to our different kinds of knowledge is just a helpful diagram about how the brain works. This is Daniel T. Willingham's diagram that I get from Why Don't Students Like School? So when your brain is interacting, it's going to be interacting with stuff in the environment, your five senses, what you can see, hear, taste, touch, and smell. And anything that you pay attention to, that you attend to, that you're aware of, or that you're thinking about, it gets placed in what they call the working memory. It's kind of like a workbench. Not too much stuff can fit on there, and you can shift back and forth, but you can really only pay attention to one thing at a time on the workbench. That's why phone numbers aren't that long, because if you have to actually remember them, you can't have a string of numbers that it's too hard to remember. So anything that you attend to, that you're thinking about, that's in your environment, it goes into your working memory. Now, if you attend to something often enough and frequent enough on a regular basis, it's going to have a really good chance of going into the long-term memory. And this could be a content. This could be like the information that you're learning in morphology class, or it could be a skill. It could be the the embodied knowledge of how to crochet, for instance, the knowing what and the knowing how. So anything that's in the working memory for a number of time, over time, will be learned and it'll be stored in the long-term memory. And then whenever you need to apply that knowledge or that practice, that skill all by yourself, you need to know, maybe you have to take a quiz on that morphology class that you're taking, or you have to crochet from memory. Like you're not, your friend's not there to help you, your YouTube's not there to model it for you. You got to do it yourself. We call that remembering. By the way, another interesting thing is memorization or memorizing is given a bad name. It has a bad connotation. It's often paired with like the word rote, which means meaningless memorization. But it's interesting. If you talk to a cognitive psychologist, like what do you call memorization? They call that learning. That's a synonym to them. And so there might be types of learning that are more valuable or less valuable than others, but learning is a type of memorization. It might be a memorization of some content, or it might be a memorization, so to speak, of a skill, an embodied skill. So memorization, we got to reclaim that word. It's not a bad word. You just say it's learning. And when you recall it, you remember it, right? You bring it back to your working memory. Now you're thinking about that thing that you're doing again. And anything that's not attended to very often over time can be forgotten. And it's not all is lost. Forgetting's not the worst thing in the world. Forgetting often is essential to remembering. I'm going to share with you in these last 14 minutes the 8 biggest cognitive science strategies. and then I'll send you with some texts, some recommended reading if you want to get started, because it's not like I don't have like a PhD or a doctorate in any of this stuff. I just hit the books and I'm kind of synthesizing and sharing to you. In fact, what I'm doing is going to be the first one I'm going to share with you. First, I'm going to share with you what I call the Fab Five. These are awesome. They're great cognitive science learning strategies, but I'm going to do a drum roll. I'm going to build up to the big three, the most important ones. So I'm building up. So these are the good. This is the good crew, but we're going to get into the most important crew right after this. So don't let your brain fool you by the first one I teach is the one that you remember the best. Because sometimes you remember the first thing and the last thing that's shared. But I'm building a drum roll. These are the great strategies. Here's the first one: is elaboration. I'm doing it to you right now. I'm teaching to you. Another one is generation. Now, these two are tricky because sometimes they get mixed up with people who do writing workshop, where elaboration means writing longer and generating ideas means coming up with something to write about. I want to sort of dispel that. They're different terms. So one thing that you might do if you're bringing this into your schools is you might come up with a new term, market it differently, and I'll tell you what they are. Then there's reflection, and what's called calibration, and mnemonics. These are the Fab Five. Let's talk about elaboration. Elaboration is what I'm doing right now. You take information that you've learned and you teach it to others in your own words. I've got my notes right up here. I'm covering the screen. I've got my notes right up here, but I try not to read my notes because it's also not, if you ever have a screen, like you should speak synonymously off your notes. But it's also, you have to make it meaningful to your life. So it's definitely meaningful to be teaching this to you, to colleagues. I think I get great value out of teaching others what I've learned. In fact, I don't think there's much of a point to learning something if you can't then share it with somebody else and lift all the boats over time. And it's also elaboration as a way of making learning meaningful to your own life. And I already said that one. Now I am looking at my notes. Making it to make sure you connect it to your learning. Okay, so this does connect to my own learning because I have been fascinated about how students and how we all actually learn. I do staff development, so I'm always fascinated how do teachers learn best? How do administrators and school leaders learn best? How can I learn best? How do students learn best? I am just obsessed with how do people actually learn with transfer and independence. And so it's inherently meaningful. So elaboration, teach others, connect it to your life, connect it to your learning. Generation does not mean generating ideas, although it's similar to inquiry. I would say it's a little bit different from inquiry. Like inquiry, you pose some sort of question or issue to learners, but unlike inquiry, it's not totally wide open. You tell the learners, like, hey, I'm going to tell you the answer in a moment. I just want you to puzzle through this problem. So generation is pose an issue, pose a problem for students to try to solve or figure out, but let them know, I'm going to let you try to figure this out, but then I'm going to teach you what it is. And so what that does is for learners, it primes the mind. You ask learners like, okay, how do you figure out this math problem? Or even previewing a text is a type of generation. What is this text going to teach us? And if you let students work out the problem or the issue before you teach it to them, their brains are ready to learn because they want to do one of two things. They want to confirm what they said, or they want to revise it and see what did I miss in that thing. So oftentimes when I have a little bit more time on a presentation like this, the first thing I'll do with the group is I'll say, what do you think are these great learning strategies? Like put them in a waterfall chat or say them out loud. And what that does is just gets the group primed for the 8 things that I'm about to share. So generation is really a great way to prime minds for learning. And the next one is reflection. That seems to make sense, but here's the key to reflection. You want to get students to ask themselves 3 questions. Number 1, a summary question. Number 2, a self-evaluation question. And number 3, I just learned on Zoom, if I do a peace sign, it does this. I have no idea why, and it's really distracting, but I get bubbles on my screen. Okay, what was I saying? Summary. Oh, I'm afraid to do it. Self-evaluation, and the third one, wow, this is messing with my own working memory because I'm paying attention to the balloons and not what I'm teaching. It's a goal setting, but you can see the questions right here. So the first one is a summary. What did I learn? Second one is a self-evaluation. How did it go? And then the third one is a goal setting. How can I make my learning even better next time? All right. Next one of the Fab Five, this one's calibration. One of the things about humans is we tend to be overconfident in what we know. I think this is something I suffered from as a student. I didn't test very well because I didn't study that frequently. I would study once and be like, oh, I've got this. And so I kind of fooled myself because I packed it into my working memory once that I could then transfer it into my long-term memory. I kind of tricked myself. So calibration is just a way to check on yourself to like, do you actually know what you think you know? You can, it's best if you're done, it's done on some sort of objective measure, like a rubric, but you could help, partners could help calibrate, like, do you know what you really claim or you think you know? And so it's just a way before you have to do some sort of academic performance, whether it's a test, a presentation, whatever, is like you check in with some objective measure. It could be a peer with a rubric. It could be some sort of rubric. Like, do you know what you claim to know or what you think you might know as well as you think you do? And to round out the Fab Five, we have mnemonics. We all know some great mnemonics. Usually the mnemonics are often in schools in the form of acronyms, but there's many others, rhymes and songs and gestures. And I would be very curious, if you like mnemonics, to get into location and image associations. There's something that's called a memory palace. And if you can attach what you've learned to your home, like coming home and the different things in your home, it's actually a great way to remember things because you're so familiar with your home that you'll like recall the information that you've learned with a lot of ease. In fact, when I used to teach these 8 cognitive science strategies, I would often recall them through coming home, and I would like attach like getting out my keys and going upstairs and opening my apartment door and entering into the kitchen area, and I was like amazed, like, wow, it's true. It seems strange because I'm not used to it. But here's the key about mnemonics. They're not teaching tools or learning tools. They are remembering tools. They're for recall. And so the key to a mnemonic is you need to know the information first. If you don't know the information first, the mnemonic is meaningless. And so if you're, marching out whatever mnemonic, cups, if you don't know what cups stands for, it's irrelevant. So the kids need to know, see, I can't even recite cups because all I know is cups. All I learned was the acronym, not the content. I think the first one's capitalization. But for a true mnemonic, you need to know the content first. Then you say, oh, and here's a quick like way to remember it, because now you know it because we've gone over it several times. If you need to remember this thing that we learned, it's called cups. Like, hey, isn't that a great thing? I think too often mnemonics, especially acronyms, are used as teaching tools. Let me teach you this mnemonic. It's cups, and here are the parts. And like the only thing that's remembered is cups, but not the content. All right, that is the Fab Five. This is the big three, the big three. So if we have to go a little bit past the half an hour, I will. I'm not going to go too far past, but these are the big three. Here they are: retrieval practice, spaced practice, and interleaving. They're all related. Retrieval practice is essentially low stakes self or quizzing in general. Basically, here's retrieval practice in a nutshell. Retrieval practice is trying to remember something on your own by yourself without any help, but it's low stakes. So the moment your memory runs out, you can go to your reference material to be like, that's the thing I forgot. It's not like you have to sweat it. It's not like you have to belabor your memory. So it's like, but do it by yourself. You have to try to remember it, if it's content or if it's like crocheting. Like you got to say, what was that move in crochet before I look it up on YouTube? Can I try to remember it myself? Oh, first I do this part. But I forgot the other part. Let me check the YouTube video. Right? That's retrieval practice. The way that you remember something is you make an effort to remember it. Makes sense, right? Like the way that things happen is if you try. That's the way that you learn something is you try to learn it. But you try, instead of like go look at your chart. What does the chart say? Try to think in your mind, what does the chart say? And then when your mind runs out, okay, the chart says this, stuff like that. But you can teach that to students. Like you can teach them, like, read a text, then cover it up, and then say to yourself, what is this text about? And then when you run out, check, what did you miss? You can do that with a peer. Teachers, you can do that. You can teach students to do retrieval practice. Like you have to be able to recall it by yourself. It could be spelling word. You need to learn a spelling word. I'm going to teach it to you, but I want you to try to recall it by yourself before you check the word wall, the reference material, the word in front of you. You got to try to remember. How did you remember all those phone numbers that I mentioned earlier? You had to remember it on your own. You didn't go looking in a phone book every time you had to call home. You had to have it memorized and you had to recall it. So the way that you remember it is you try to, and I have a tough time with this because now our phones do all the remembering. And so, God forbid I'm in some sort of emergency where I have to call my wife and I don't have my phone or whatever, like, I think I can think of it. I think I've got it, but like I have to think about it. It's not like 369-876, like which I haven't, you know, dialed in 35 years. All right, the next huge one is space practice. Space practice means doing this like retrieval practice or doing the learning over time in small packets. For those of you who are familiar with a lot of the things that I put out, like word love and word love morphology, and if you're on the grammar pilot, I am all about the space practice. Let's just do things for a few minutes a day across time instead of like, let's do it all for 1/2 hour chunk. That's called mass practice. If you do something all in one huge chunk, it's called cramming, by the way. And we all did it in college to pass that all nighter, pass that midterm. We pulled that all nighter to pass the midterm, but we don't remember anything from that class because we overloaded our working memory, and it's not as durable learning. More durable learning is doing it again and again in small packets over time. We all know this, and this one's common sense too. Like if you're learning an instrument, you're probably better off practicing just 10 minutes a day than just like, one day a week for 45 minutes. Everybody would say you're going to, even if you do a few minutes, you're going to get a lot better. That's spaced practice. What's interesting about spaced practice is once you've learned the thing that you need to learn, the spacing can double. So initially when you're learning something, the spacing should be like every day or every other day. Like you shouldn't like teach some information that you want to come back to and then do it on like a Monday and then a Thursday. Come back to it no later than like a Wednesday. So you want to do 1 to 2 day jumps, but once something is learned, then you can double it. Then you can go like, all right, now that you know this, we're going to come back to it in a week. Now that you know this, we're going to come back to it in 2 weeks. Now that you know this, we're going to come back to this in a month, 2 months, 4 months, 8 months. You keep going. You can that's like a rule of thumb. It's not hard and fast rule. There's a lot to learn, at least from what I've read. There's a lot to learn about space practice, like what is the timing. But it seems to be initially the spacing needs to be very close and not in huge chunks. But as the information is actually learned, you still need the space, but you can like double the timing. And then the last one is basically interleaving. This one is the most counterintuitive, and it's a challenge. It's like really it's going to make the brain's gears work, but in a good way that leads to durable learning. Now, most people think when you want to learn something, you want to just do mass practice, get it all in at once. But interleaving is basically space practice and retrieval practice all wrapped into one. So let me use an analogy for space practice. Let's say you're studying trees. Let's use that as a content. Instead of just first studying all about oak trees and then studying all about maple trees and then all about pine trees, you'd mix it up. On day one, you'd study a little bit about oak trees and a little bit about pine trees. And maybe on day two, you study a little bit about maple, and then you go back to oak trees. And on day three, you go to pine trees and maple trees again. You see what I'm doing? Here's what interleaving is when you study related but different material. So for something like, I guess, crochet, but let's say you want to learn a bunch of different sort of like knitting crafts. You'd practice a little bit of crochet, but then you move to your knitting. And then you maybe move to your needle point and then back to your knitting and then back to your crochet and your knitting. And then you interleave it in that way. And so some of this has some implications for research. So if you're asking kids to like research animals, instead of just researching one animal, maybe they research two at once, or they research two subtopics at once, or three if they can handle it. Instead of like, I'm just going to study animal habitats for the frog, you might say, I'm going to study their habitats and their diet, and I'm going to go back and forth in this one session. This is harder. It's harder learning, but it's more durable. And I do this myself now. When I read an audio text on a topic, I mostly read nonfiction these days, although I am an English major. I usually will get 2 books on the topic, and every chapter, I'll interleave the chapters. I'll listen to chapter 1 of book 1, then chapter 1 of book 2, then chapter 2 of book 1, and chapter 2 of book 2. And sometimes I'll let 2 get a little bit ahead, so that I'm like, oh, let's go to chapter 3 of book 1, and then we'll do 3 of book 2, and then 3 of book 1. But the point is this shifting back and forth is going to lead to more durable learning, and it's definitely worth exploring a little bit more. But I just wanted to give you the big stuff. Here's some books if you wanted to do a little studying. These I've all read, so I can vouch for them. This is sort of my mini library my mini, tech set on this topic. I'm going to say the best ones are the first 3 on the top left. The number one, head and shoulders above the rest, is Make It Stick: The Science of Successful Learning by Brown, Rediger, and McDonald. This is the one book in my life, especially recently, but it's the one book, the only book. I'm not exaggerating. It's a true story. This is the one book that I've recommended to people, and I recommend books to people all the time. But this is the one book where people have sought me out later, usually months, sometimes years later, and they say, "Mike, that book was a really good book." And I'm like, "Really? Wow, that's great. I thought so too." But it's the only one. And so I just want to let you know, if you wanted to start somewhere, maybe that's the one. And I think it's a good book for a couple reasons. It's gonna be so practical to your teaching life. You're gonna be on fire, like, oh my goodness, I can do this in the room right now. But it's also gonna be practical in your personal life. You're like, oh my goodness, this hobby that I'm learning or this new thing that I'm taking on, like, I need to be doing these things. It does a great way of like shifting between the research, where it's all like sort of really heady and nerdy, and narratives. Like, they tell a good story to illustrate it, like really good. And the other thing that's important here is the second author, Rediger, is the author that's like cited in all these other books when it comes to these strategies, because I guess he does a lot of the actual research. So I think Rediger is maybe the scientist. He's like the researcher in that book team, and maybe I have to look again, but maybe Brown is like one of them's the writer to make it beautiful. But Rediger's like the source guy. Like, these other books, like, keep talking about Rediger, Rediger, Rediger. Like, all right, so this is the guy to go to for these cognitive science strategies. So Make It Stick is your number one book. Another one that's fun is How We Learn by Benedict Carey. Now, this book is very friendly to a popular audience. He's a journalist, so he shares a lot of the same information as Make It Stick, but he does it in a very entertaining way, and he draws you in a very clever way. He does it in his own way, but he's going to share a lot of the same information. In fact, if you want to do some interleaving yourself, you might interleave these two books, by the way, if you're interested. Daniel C. Willingham is great. He's a cognitive scientist who can really explain things to a general audience. And so, Why Don't Students Like School is a classic that he just had the second edition he just published a couple of years ago. I haven't read the second edition. I read the first one, but it's a really, really good one. And you'll see another book down there, Raising Kids Who Read, which is for parents, but as teachers, like, we get so much practical information. And he has a lot of good stuff there. And then Hattie's work, Visible Learning and the Science of How We Learn, I think that's really good for teachers. That really angles towards teachers. But one of the things that I love about Make It Stick and How We Learn is, like, you're going to feel like not only is it pertinent to you as a teacher, but also it's something you can actually teach kids to do by themselves. And you're going to be doing it by yourself in your own life. How We Learn leans a little bit more into the neuroscience. He does kind of go back and forth into cognitive psychology and neuroscience, but he's more interested in AI. And so I don't know how practical to be. And that's a little bit more heady, but he does cover some of the same ground. And then Sanjay Sarma from MIT wrote a book, Grasp. It's not, I don't think it's as good. The stories aren't as good, and the teaching isn't as great, but it's another one there. And he'll cite a lot of the big three, but most of them do. Like, the big three are the big three for a reason: retrieval practice, space practice, and interleaving. So, my colleagues, thank you for joining this session. And I hope you got some information from it that will be useful to you, or at least stoked your curiosity. There is ways that you can stay in touch. There is a small community of colleagues where I'll be sharing more stuff along this on my Patreon. But just stay in touch. I have an article that I want to write about to teach it. But this isn't the end of the science of reading. If you want to continue to be curious about it, it'll really open your eyes, and you're going to see kids really learn with transfer, with power and effectiveness. So thanks for joining me on Monday evening, and I wish you a great rest of your week. Stay in touch if you need anything. Good night.